Welcome back to Bite Size STEM. Today we're going to talk about the aging page replacement algorithm. So let's go ahead and dive into it. So first we're going to go ahead and draw a bookcase, and today we're just going to be looking at just one bookshelf on the bookcase. Now this bookshelf is going to represent the computer's memory. Each individual book on the shelf corresponds to a page in the computer's memory. The pages are units of memory that store information, similar to how books have their own pages that contain content. So when we visualize the books representing pages, it's like looking at a snapshot of the computer's memory at a particular moment. The aging page replacement algorithm helps manage these pages on the bookshelf to ensure efficient use of limited memory space. Now we're going to go ahead and dive in to how exactly it does that. To efficiently manage these pages, we're going to talk about three key terms today. We're going to talk about the referenced bit, aka R bit, the aging register, and the aging page replacement algorithm. First up, the reference bit, or the R bit. Think of it as a bookmark in a book. Every time a page is read, we place a bookmark on it. The bookmark, or the R bit, helps us know which pages have been accessed recently, or that we've already read. Now let's introduce the aging register. I'm drawing a clock here. The aging register is like our timekeeper, ticking away regularly. It keeps track of time for each page in memory. As the time passes, the aging register updates the pages, indicating how long it's been since they've been accessed. The more time that elapses, the more ticks the pages get, aging them in our memory space. As you see, I do arrows to the books as it's ticking and aging them. It would go to every single one on the bookshelf. I'm just demonstrating how it's going to do that over time. So it's going to keep doing that, and the more ticks that a book has, or a page in memory, that's indicating how long it's been since they were last accessed. Now it's time to tie it all together with the aging page replacement algorithm. When it's time to replace a page, we consult the aging register. Pages with more ticks, meaning they haven't been accessed recently, are considered older. It's like retiring an old book from our limited shelf space. If you haven't read anything recently, say you have an old book that you read 2 years ago, then there's no use in keeping it. You're not going to read it again. You can give it to somebody else. You can free up some memory. And there you have it, the aging page replacement algorithm in a nutshell. We use the R bit to keep track of accessed pages, and the aging register to measure time, and the algorithm to decide which pages to replace based on their age. I hope this whiteboard session helped clarify these concepts for you, and if you enjoyed this video, don't forget to give it a thumbs up and subscribe for more tech explanations.